Hello and welcome to Khan's Tech Lab. As we are working on the logic series and we have covered a few sessions already, and the last session was resolving the palindrome using Java. In this session, we will learn how to resolve prime number using Java. So before that, let us understand what is a prime number. As we already know, prime number is a whole number or a natural number which is greater than 1 and which has only two factors or two divisors, 1 and the number itself. The two divisors should be 1 and the number itself. For example, 2 is a prime number. 2 can be divided by 1 as well as 2 can be divided by itself, which is 2 by 2. So it is a prime number. And 2 is the only even number which is prime. Apart from 2, there is no prime number which is even. Now let's go to 3. 3 is also a prime number. 3 can be divided only with 1 and by 3 itself. Similarly, 5 and 7 and 11. There are so many prime numbers as you can see in the image on the right side. We have counted prime numbers from 2 to 100. Now, there are a few categories of numbers which we call composite numbers. Composite numbers are actually the opposite of prime numbers. We will deep dive into this in the upcoming slides. Now let us go to the definition again. A prime number is a natural number and it should be greater than 1 and it should not be a product of two small natural numbers. For example, 2 into 3 is equals to 6. So two natural numbers are multiplied here and it become one more number which is 6. Whereas if you can think of 5, 5 cannot be generated with the multiplication of any two numbers except 1 and 5. So now let's understand the factors. As you can see, a factor of number divides evenly into that number. For example, the factor of 6 are 1 and 2 and 3. Like 1 into 6 equal to 6, 2 into 3 equal to 6. Now, coming to the prime versus composite comparison. As you can see here and also we discussed just now, a prime number has exactly two factors, 1 and the number itself. Whereas the composite number has more than two factors like we saw just now 6. 6 is composite because it has more than two factors, 1 and 2 and 3 and 6. 1 into 6, 2 into 3, 3 into 2 and 6 into 1. So 6 is a composite number. Now let us understand the detailed explanation of the examples of a few prime numbers or composite numbers. 2 is prime, factors are 1 and 2. 3 is prime, factors are 1 and 3. 4 is composite, factors are 1 and 2 and 4. 1 into 4, 4. 2 into 2, 4. 4 into 1, 4. So it's more than 2. Whereas 5 is a prime number. It has only two factors, 1 into 5, 5 into 1. Similarly, 6 is composite, 7 is prime. Also, the number 1 is not prime. It is neither prime nor composite because it has only one factor which is itself. So now as we generally discuss what is the use case of any logical problem we discuss like even factorial or palindrome or any other thing. Here also we are discussing the prime number use case. Prime numbers are the fundamental building blocks in number theory, and it has several applications, especially in cryptography, other fields. There are so many fields where we can address the prime number use cases. So let us summarize what and all we learned. 0 and 1 are not prime numbers. 2 is a prime number and is the only even digit which is prime number. And if the number is greater than 2 and it is even, then it is not prime. So three conditions we have so far covered. 0 and 1 are not prime numbers. 2 is a prime number and 2 is the only even number which is prime. And any number which is greater than 2 and it is even, then it is not prime. Apart from these, the other categories which has two factors, the number 1 and number itself, then it is called prime number. Now let us understand through Java code how to create or how to check whether a number is prime or not. All right, let me create a Java class and I will call it prime number. As this is a standalone application, I will add a main method. Now I will take number input from the command line. For that, I need to use scanner class. Scanner equals to new scanner and I will use system.in to take the input. Now I will create take a variable number which should be scanner.nextInt. So whatever integer the user gives as input, it will be taken as the number on which we will perform the prime number check. First thing, 0 and 1 are not prime. So let us add an if condition. If number is less than or equals to 1, then we are printing the given number is not prime. Let us test this, then return. Let me test this. So I will just give one print statement in order to know the use, in order to inform the user to enter a number. Please enter a number to perform prime number check. Let me run this. Now the application is asking me to enter a number to perform the prime number check. I am entering 0. As you can see, as per our condition, 0 is not prime. Now let us enter 1 as the input. As you can see, number 1 is also not prime. Now, our first condition is satisfied here. We will move to the next condition, which is the number, if it is equals to 2, so 2 is prime. So if number equals to 2, then just print the same kind of statement but with prime. So The given number 2 is prime. Let me save it and let me run this. Now let me enter the number as 2. As you can see, the given number 2 is prime. So we have covered 0 and 1 and 2. Now we will write the actual logic from 3 onwards. So now checking whether a number is prime from 3 onwards. Now let me take a boolean is prime, whether the number is prime or not, we need to know. And let me trick is test true. We will assume the given number is prime. Then we will write a for loop. As you know, we will try to divide the number with so many numbers. For example, if we are trying to divide, for example, I want to test the prime number for number 3. Let me show you using the Excel sheet. So now, for example, I want to know whether a number is prime or not. So I am taking 10. So I want to know whether this is prime or not. So 10 can be divided with 1. 10 by 1 is 10. 10 can be divided with 2. 10 by 2 is 5. 10 can be divided. 10 cannot be divided with 3 and 4. 10 can be divided with 5. 10 by 5 is 2. And 10 it can be divided by 10 itself. So these are the 4 factors. So we need to understand we should perform the division operation only until here. We need not to do it for 10 because we already know it can be divided. So now 1 and 2 can also be removed because we already know. Now only 5 is left. There is a mechanism by which we can understand until what maximum number we can divide. So, for example, if it is 9, we can take a square root of 9, which is nothing but 3, and we can use the divisor until 3. So similarly, if it is 16, we can divide it until 4. If it is 25, we can divide it until 5. Let me use this same logic inside the code. So I am consider this I as the divisor by which we are dividing the actual number. So here I is the divisor and number is whatever number the user enters. But there is a condition here because we already checked for 1 and 2. We will start it from 3. Now I equal to 3 and this I should be less than or equal to square root of the number. There is a function using which we can perform the square root. If you want, we can just take this out from here and take a long or double square root variable and we can use it here. Now, I should be started from 3 and 3 should be less than or equal to the square root of the number. Then 3 should not increment every time, because if 3 plus 1, it will be 4, and it is again an even number, and it has more than 2 factors. So I will make it I equals to I plus 2, so that we can maintain the odd numbers alone. Now I need to do one if condition, which is nothing but I, the number modulo I, should, if it is equal to 0, then it is not a prime number. So isPrime will become false. Now we missed one condition here. We can write one more condition before we go to the actual logic, which is even number logic. So even numbers are not prime. Over 2, if the number is greater than 2, so it will just print this, it is a prime number, and return. But if it is not 2, then if it is greater than, if it is not 0, not 1, not 2, and but it is even number like 4, 6, etc. For that also we can write a condition: if number modulo 2 equal to 0, then also it is not a prime number. Let me just use this and paste here. All right. So we have checked the even numbers also. If you want, I can just run it again and just show you. If I just enter any number, which is neither 0 nor 1 nor 2, but any random even number, it will give as the given number is not prime. Let me try for something else. 8. As you can see, 8 is not prime number because number modulo 2 will be equal to 0, and which means it is an even number, so it is not prime. Same logic, number modulo I should not be equal to 0. If it is 0, it is not prime. Otherwise, it is a prime number. So now let me write a print statement out of here. So the number is prime. This statement is correct or not? Let us see here by giving this is prime boolean value. So now let me run this. I will enter some random number like 21. If you can see 21, first condition is number less than equal to 0. So either 0 or 1. So 21 is neither 0 nor 1. So it will not go inside this if condition. Then whether it is 2, so number is not even 2. So it will not go inside this condition. Then the third condition, is it a even number? It will check number modulo 2 equal to 0. 21 is not an even number as well. So it should not go inside this if condition. Then finally it should come here. So let me try to run this. First, I will just show you whether it is prime or not. So as you can see, 21 is not prime. As you can see, the number 21 is prime. This statement is false. So it is not a prime number. How come? So 21 has more than two factors. 21 can be divided by 1. 21 can be divided by 3. 21 by 3 is equals to 7. 21 can be divided by 7. 21 by 7 is equals to 3. And 21 can be divided by itself, 21 by 21. So it is not a prime number, and the statement is correct. So now let me show you by debugging this application. Now, so first thing, I will add a breakpoint here. First, let us take the input from the user. So it is asking, please enter a number to perform the prime number. So same 21 I will take. Now, number is 21, less than or equal to 1, which is false. So it will not go inside this if condition. So now it came to the second condition. Is number equal to 2? 21 is not equal to 2. So this condition is false. So it will not go inside this, rather it should come to this line number 23. As you can see, it came to line number 23. Now the control is here. Now the 21 modulo 2 is equals to 0. Is this statement true or false? So this is false. Let me show you a quick thing for this modulo. As you can see here, if I divide 3 with 2, so 2 into 1 is equals to 2 and the remainder is 1. So this is 1. So the 3 modulo 2 is equals to 1. Similarly, if I just do like this, 2, 21. Now, how many times we need to multiply 2 to get 21? First, we will multiply with 10. Then, what is the value? 20. Now, is 20 equal to 21? No, we have a remainder which is nothing but 1. So, here the remainder is 1. So, 21 modulo 2 is equals to 1, which is not 0. Now, our condition is 21 modulo 2, which is not equal to 0, which is actually 1, as you can see here. Now, this condition will also fail. This condition basically tells us whether that number is even or not. Now the actual logic started. So we had taken a prime number boolean value, which is true, and now we are doing a square root. So we are getting the square root as 4.5. Now the value 3 should be less than or equal to square root, which is 4.5. So the condition is true. It went inside. Now we have a condition. So number modulo 21. The number is 21 modulo 3 is equals to 0. 21 by 3 is equal to 7. There is no remainder. So it will go inside this. So as you can see, previously the prime number or isPrime boolean value was true. Now it will become false. As you can see, if I hover it, the isPrime has become false. Now, now we are incrementing the I value with 2, which is 5. 5 is less than or equal to 4.5. So the condition will fail and the control will come outside of the for loop here, and it will say the number is not prime. So the statement the number 21 is prime is false, which means the number 21 is not prime. Whereas if I can just use 23, 23 should be prime because 23 has only two factors. 23 can be divided by 1 and 23 can be divided by 23 itself. So the statement is true. So this way we can understand the prime number, whether it is a number is prime or not using Java. Hope you like the video. If you like the video, please share the video with your friends and also hit the like button and also subscribe to our channel. Thank you.